Hello, yes, and welcome to our Objective 1.1 sample problems, where we're going to do some more problems over Objective 1.1 that states I can define a function and determine if a relation is a function. Now for this one, we're really going to focus on the second half of this objective, determine if a relation is a function. So let's look at these graphs that we have here, letter A and B. So to determine if a graph represents a function, we use the vertical line test. And to do that, we just need to imagine taking a vertical line across the graph. If it touches more than one spot, it is not a function. If it only touches one, it is a function, since this, as we take it across, only touches one part of the function, it is indeed a function. So we would say yes for this, for letter A. For letter B, however, notice if I take it across, oh, I'm touching multiple parts of the function. Do we see that? So let's say like -5 is my input here. So if -5 is my input, I'm touching the function here and here. So that tells me then that this is not a function. Okay, so let's go ahead and scroll down here. Let's look at C and D as well. If I take a vertical line across letter C, there we go, take it right across. Notice it looks like I only touch one part of the function at a time. So that means that C is a function, or it passes the vertical line test. Letter D, taking it across, well, we're really good to the right. I'm not too sure though. I mean, I can see clearly that this is going to pass the vertical line test, but what about over here on the left? Notice how, look there. Yeah, I'm definitely touching multiple spots. So like if x is -9, I have a couple outputs, one right here and one right here. So that tells me then that this is not a function. This relation is not a function. So that's graphically how we can determine using the vertical line test. So let's do some algebraically. Determine if y is a function of x algebraically, show you where. So remember, for this, our goal is to get y all by itself. So if I'm looking at letter A and I want to get y all by itself, oh boy, I'd start by subtracting x minus 3 squared. So I would say y minus 6 quantity squared equals 25 minus x minus 3 squared. Oh boy, and I can see right now we're in a tough spot. So I have a square root, or I have a square here, so to get rid of that I need to square root. Now whenever I do a square root, remember I need a plus or minus. That's why I will say y minus 6 equals plus or minus the square root of 25 minus x minus 3 squared. Then to get y all by itself, I just add 6. So this tells me that y equals 6 plus or minus the square root of 25 minus x minus 3 quantity squared. So here's a pretty big giveaway. If we have this plus or minus, that tells us for one value of x, I'm going to get multiple values for y. So that means for one input, I get multiple outputs, which means that y is not a function of x. There we go. All right, letter B, 4/3 x minus 2/5 y equals 1/2. Oh boy, okay. Fractions, that's okay, it doesn't change what we're doing. So let's try to get y all by itself here. So we'll subtract 4/3 x, so I'll have -2/5 y equals -4/3 x plus 1/2. And I can multiply everything by 5. This will be fun. So if I multiply this side by 5 and this side by 5, I would get -2y equals -20/3 x plus 5/2. And now I need to divide everything by 2, which is the same thing as multiplying by 1/2, of course. So I would get y equals -26x plus 5/4. And you're probably saying, Mr. Carter, do I need to simplify that? Well, no, not really. The goal here is just get y by itself and determine if when I put in a value for x, I get more than one value for y. So if I put in a value for x, say 1, I would get negative 20 over 6 plus 5/4. That's just going to give me one number. That's going to give me one value for y. That means for one input of x, I get one output of y, which tells me that y is a function of x. Very cool. All right, let's look at letter C, some absolute values. Sweet. So, to get y all by itself, I'll add 8 to start. So 4 times the absolute value of 2y will equal 30, and then divide by 4. So the absolute value of 2y will equal 30 over 4. Now remember, when we're doing absolute value, we then split this equation into 2, because absolute value is the number's distance from 0, so that means it could be positive 30 over 4 or negative 30 over 4. So we'll say 2y equals 30 over 4, or 2y equals negative 30 over 4. And then when I divide by 2, I'd get y equals 30 over 8, or y equals negative 30 over 8. Well, think about that. I don't even have an x value in this equation, but I'm getting multiple values for one y. What do you think that means? If I get multiple values for y, that tells me I'm not just getting one output. So that means that y is not a function of x here. Very good. All right, so let's look at letter D. Get y all by itself. I add 4, so 3y will equal 4 plus the square root of x minus 5, and divide by 3. So y equals, you can say 4/3 plus the square root of x minus 5 all over 3. Now this one's tough because if we look up above at letter A, we had a square root and we had the plus or minus. Now notice that plus or minus came because we performed the square root. On this one, the square root's already given to us, so there is no plus or minus. So if I plug in a value for x, I'm not going to have the positive and negative. It's just plus. So that means that this, for one input, I would only get one output, which tells me that y is a function of x. Beautiful. All right. Looking at letter E, oh, we have y squared all by itself, but I know I would need to take a square root of y squared, which means I'll be taking the square root of x squared minus 8x plus 16. So if I am doing the square root, this is just like what we talked about. If the square root's given, we don't need a plus or minus. But if we make the square root, we do need the plus or minus of x squared minus 8x plus 16. And that tells us, pretty straightforward, well, we're going to have multiple outputs for one input, so y is not a function of x. All right, last one, letter F here. Y minus 3 equals the absolute value of 2x minus 5. To get y all by itself, I just need to add 3. So y would equal the absolute value of 2x minus 5 and then plus 3. If I plug in a value for x, am I going to get multiple values for y? So absolute value, think about what we did up here. If y is inside the absolute value, we had to split it to 2. But since x is inside the absolute value, we don't need to create multiple equations or anything like that. If I plug in a value, say 0, I would get the absolute value of 0 minus 5. The absolute value of negative 5 is 5, right? It's not positive 5 and negative 5, it's just 5. So I'm only getting one number out of this, which tells me I only get one output for every one input. So that means that y is a function of x. All right. And that's it for our sample problems. Hopefully we're feeling confident with Objective 1.1 now. Go ahead and look at those practice problems if you haven't yet. Let me know if you have any questions. And this is Mr. Carter signing off. I'll see you next time.